Hi, welcome to the part 3 of this video. So far, our bot is able to collect flash loan from Aave V3 and is able to repay it. We saw that in the part, we did that in the part 1 and part 2 of this video. So what we are going to focus on is to ensure that our bot is able to make money for us, and that's by being able to swap on multi-dexes. Um, our bots will be able to swap on Uniswap V3, Aerodrome V2, Pancakeswap V3, Sushiswap V3, and Alien Base. So let's jump to the ID and get started. All right, let's quickly list out what we are going to do. Now, you need to understand that dexes are also smart contracts. And in Solidity, for you to interact with another smart contract, another deployed contract, you need two things. The first thing is ABI of that contract. That's contract ABI. And you also need the contract addresses. So those two things, we are going to integrate them into our contracts. Now, contract ABI, we can also use contract interfaces because the compiler compiles the interface of the contract we want to interact with down to its ABI. So it's a lot easier for us to work with the interfaces. So these are the two things we are going to need for each of these decks, for each of these dexes. And so let's start. Let's create a folder here. Okay, we have interfaces created here. So let's create another file and we're going to call it idexes. So this will hold all the interfaces for our dexes. Now, here are the interfaces for each of the decks we are going to work with. And we need to also define the Solidity version. So let me just copy that from here and put that in our interfaces. I'm going to go over this so that you guys can see the interface and type along with me. Basically, interfaces define functions in a contract that you can call, that you can interact with. So the first interface here is for Aerodrome V2. We're going to call this function swap exact tokens for tokens. We'll also play with this get amounts out, and this is a struct we are going to also work with. Please feel free to pause this video and copy these interfaces. For Uniswap, for Sushiswap V3, this is the interface we'll be calling swap exact tokens for tokens. That's the name of the function for swapping. Get amounts out help us to calculate the slippage, and you'll see how we'll use that. For Pancakeswap V3, this is the interface. We need a struct, and we'll be calling exact input single for swapping. For Uniswap V3 router, this is the interface. The good thing is Alien Base has the same interface with Uniswap V3, so we'll be using the same interface for both of them. We'll be calling exact input single for them. If you notice, both of the Uniswap V3 and Pancakeswap V3 have a similar interface, but there's a major difference here. This Pancakeswap V3 has deadline as one of the parameters in the structs, but here in Uniswap V3, there's no deadline there. All right, so these are the things we'll be calling. So I'm going to import this file into our multi-dex bot. So this will be imports, and the things we are importing, the names of each of them. I just don't want to include everything in this multi-dex bot file. Otherwise, it will just be unnecessarily long and I would have to be scrolling up and down to call. All right, so we have, I'm defining the location of the idexes is inside the interfaces. Then the next one are the functions there. Okay, copy this. Then you paste it. Oh, it's the name of the file I'm supposed to paste here now. Dexes.so. Alright, it sees it. Alright, let me do sushi. This is Pancake. Swap V3. And the next one is, and the last is Uniswap V3 router. Yes. Now we are going to implement a function here. As I said earlier, the function will probably call it execute trade. What is going to do, before I comment it out, is just to do swap on 2 or 3 of the dexes based on the arbitrage opportunities that we have seen, and based on the parameters we will pass in from here, and tell us our final amounts here. So we have to implement this, and it's going to be an internal function. So let me comment it out, and we will jump down here and create the internal function. So we are going to create an internal function, and it's going to be, we are going to call it execute trade. We have to pass all the necessary parameters in. Internal functions is going to returns in 256. So we are going to start with the dexes one after the other. Now this internal function will call other internal functions like swap on Uniswap V3, internal returns. We want it to return Uniswap UN256. Function. So based on the condition we specify here, this internal function will call this. So let me comment it out first. So we'll still have another function, because it's always better if you keep your code in a modular form like this. Pancakeswap V3. That will also return the same UN256. This will be okay. Pancakeswap. This will be Sushiswap swap V3. So each of them will be called one after the other based on the condition we specify. I'm just giving the layout first. Now to comment out, you just need to do Command L, and that line is commented out. Now let's start calling the necessary functions. Now for Uniswap V3, let's check the interface and see what we're going to need. Uniswap V3, we are going to call this exact input single function. We'll pass in our parameters, and it's going to return amount out in unit 256 for us. So let's do that. So that means that we are going to have something like this. Yes, Uniswap V3 router will pass our params to it. Let's try and break the params down. The params is a struct and it's defined this way. So from the interface, we import this struct, the exact single params struct, which is this. So exact single param struct, we import it here. Then we define this params struct. Then we pass our parameters in. I'm going to define this internal function later, which is calculate min out. This is how we are going to be able to calculate our minimum amount out, which will help us to calculate slippage. As we go along, I will explain the importance of that. Now, we need to define these parameters. Uniswap V3 router, we need to define it. So let's come here, and it's going to be Uniswap. Okay, Uniswap. I'm going to make it an immutable function, an immutable variable, and that is quite important because number one, once it's immutable, it saves storage space, so you save gas fees. That's one. Number two, this will set the contracts at during constructor in the constructor. So that means it will be set once and for all in the life of the contract. So as we are deploying this constructor function runs and it sets all the parameters, including our Uniswap V3, and we are going to pass the address of the Uniswap V3 router into it. So we need to wrap Uniswap V3, the address you're going to pass in, we need to wrap it around with Uniswap V3 router interface. So I'm going to have here another parameter for deployment. Should be Uniswap V3 router. I'm going to include that. So when it comes in, we'll pass it to this state variable, and we'll set the contract. Then we can now start calling our contract. Okay, this is all right. Okay, over here. Now it's defined. All right, so we need to now define all these other parameters. Now these are the parameters we need to define. All right, so we have amount in. Amount in is, let's say we want to swap USDC to WETH. So amount in is the amount of USDC we are putting in. Token in is the USDC address we are putting in. Token out is the WETH we want to get. Pool fee is the particular Uniswap pool we want to swap on, and latest price will help us calculate the slippage. So we can get the latest price by either integrating Chainlink into the contract or calling directly on the back end to Uniswap V3 contracts. There's a function called slot 0 on Uniswap V3 contracts, and you can get the latest price there. Then we'll pass it in. That's what we'll be using here. Now, why do we need calculate minimum amount out? This function, and it's quite important. Now, in Solidity, there's what we call miners extractable value, MEV. Now, it allows miners, those processing transaction on Ethereum network, to rearrange transaction in order to maximize their profits. So transactions are not arranged based on which transaction comes first, but based on who pays higher gas fees. So that means that if I send a transaction to swap on Uniswap, my transaction goes to the mempool. Mempool is publicly available for everybody to see, and there are bots that constantly look at the mempool. So once my transaction is significantly large, these bots will front run my transaction. They will send their own transaction to Uniswap. Now, they are going to do their swap first because they are going to submit their transaction with a higher gas fee than mine, even though mine comes first. Then they are able to do their transaction first. We call that front running. So after they do their transaction first, the price would have moved. So let's say I submitted my transaction when if wrapped it is 1,800. They would make their own transaction first and get that 1,800 price, and the price would have moved. Let's say it has become 1,805 USDC. Then my own transaction comes in. Then I will also do my swap. So let's say because I do my swap at 1,805, the price now moves to 1,806. Then they cannot swap back. We call it back running. They front run my transaction and back run it, do another transaction immediately to take advantage of the arbitrage. So they were able to buy at 1,800 and sell at 1,806 because of my transaction. So they would ensure that my transaction fills at the worst possible price. So that's why calculate minimum amount out is quite important. It's us telling Uniswap that this is the minimum amount of token I want to buy, wrapped it, that you should give me. If the price is above 1,800 or 1,801 that I want to buy, cancel my transaction. So that's the whole essence of this. So this is where we're going to use our basic math. This is the code we're going to use. It may look daunting, but I promise you it's not. All we are actually doing is that we are telling it that based on this slippage, calculate the minimum amount you want. If it's less than 99% of what we want, for example, that's 1% slippage. We don't want it. Just cancel the transaction. But there are a few parameters we need to define here. Now, if it doesn't make sense now, please be patient with me. I promise you it will. So there are a few parameters that we have not defined here. Slippage, norm, times e raised to power 8 and whole percentage. So let's quickly go up here. That would be a constant. These are constants. Now, the slippage numerator multiplied by 10 raised to power 8. This represents 0.5% slippage. So what we are doing, and you can see a whole percent is 10,000 times 10 raised to power 6. What we are doing in Solidity does not undo floating numbers, well, numbers with decimal places. So it just round it down. So we need to ensure that we are using big numbers to ensure that when it rounds it down, it doesn't affect our calculation. So that's why instead of using 99.5% here, I'm using 9,950, and for a whole percent, I'm using 10,000. All right. So let's come back down here, and please feel free to pause this video and write this code down. So basically, we made calculation based on the pairs we are swapping. So for example, if we are swapping from Coinbase Bitcoin to wrapped Ethereum, so this is how the calculation will be made. The amounts we are putting in multiplied by our slippage numerator. Then we need to compensate. We need to compensate for the decimals of the token. So ERC20 tokens have different decimals. So we multiply by 10 raised to the power 18, and based on our price too. Then we divide by whole percent. If we are swapping from worth to Coinbase Bitcoin, we'll use this formula. The same thing if it is worth to Coinbase Bitcoin. So we are going to use this formula to calculate our amount out. Then if we are going backward, we have from Coinbase Bitcoin now to wrapped Ethereum, we use this. Then if we are dealing with USDC to wrapped Ethereum, this is what we are going to use. Now you need to know that USDC decimal is 6. So 10 raised to the power 6. For wrapped Ethereum is 10 raised to the power 18. Then we use this for, so if we're swapping backward, it will be this formula. Then if we are dealing with other I call them exotic pairs like wrapped Ethereum to Aero, we'll be using this calculation. And if it is backward, Brett or Aero to wrapped Ethereum, we'll be using this calculation. If all we are dealing with is stable coin USDC to DAI, we'll be using this calculation. Then we return the final amount. All right, so feel free to pause and copy this down. All right, so let's define the remaining parameters. So this will be the addresses of these tokens. So I'm going to come here where I have my constants, and that's where I'm going to define all of them. All these you can get them on base scan. So we've defined all of them, and hopefully must have, yeah, everything is okay now. We need to be able to adjust our slippage based on the market condition. What we've done here, we've hard coded it to 0.5%. So we should be able to adjust it to 1%, 0.1% based on market condition. So I'm going to add a function for that now. So set slippage, and it's restricted to only owner. So we can pass new numerator to the slippage. Then the slippage, of course, must not be more than 100%. Then based on this calculation, so if we pass in, for example, 0. We have to pass in something less than 10,000 times 10 raised to the power 6. So this is times 10,000. So what we are passing in would be something around maybe 1,000. 1,000 goes for 1%. So the 1,000 times 10 raised to the power 6 will be taken from 10,000 times 10 raised to the power 6, and that becomes our new numerator. Now I need to define this event, which will be emitted once we change once we update our slippage. It's an event, and it's in 256. Sorry, earlier I said this is a constant. It's actually not a constant, it's a storage variable. So let me just move it down. It's a state variable. So let me, all right, this is a constant. Now let's define this error up here, slippage to I. Then we'll compile the contract. Hopefully it compiles. Forge, build. Okay. All right. The main problem we are having is with our deploy script. Well, besides that, everything seems to be okay. No problem. So with this, it's because we've changed the constructor. We now have 2 parameters in the constructor instead of 1. So let me show you the deploy script. We still have it. So we need to update that. Well, we'll do that as time goes on because we still add more parameters. All right. With this, we've finished adding Uniswap V3. We'll need to do Pancakeswap V3. For Pancakeswap V3, interactions, no, over here, supposed to come here. And what do we need? Exact input params. It looks more like Uniswap V3. So I promise you it won't take as much time as Uniswap V3. All right. So this is what we need. Swap will pass the parameters in just as with Uniswap V3. Then it also requires a struct params. We need to define duration, the deadline. Deadline is us telling Pancakeswap V3 complete our swap within 10 seconds, 5 seconds, otherwise revert the transaction. So that's also to protect us from MEV bots. All right, so we need to define this duration. I'm going to go up, and this is our minimum amount. Let's define Pancakeswap V3. The contract address will come in as before, as we did for Uniswap V3. So once it comes in as a parameter, you're just going to, oh, sorry about that. I'm supposed to define it here. I'm going to define the Pancakeswap here, the contract itself. Then I'm going to take in the contract address in the constructor and wrap it with the interface, the Pancakeswap V3 interface. I'm going to put it here, one of the constructors, and this is how we are going to do it for. Okay, I need to put address here. Okay, it's okay now. Now we need to define this duration. It must be a constant in order for us to also save gas fees. So I'm going to put it here. It's going to be unit 256 public constant duration, and I think 15 seconds is okay. It could be lesser. We're just saying that it should swap between 15 seconds. And by the way, everything we are doing is within one block, which is about 2 seconds on Base blockchain. So for Pancakeswap, let me look at it again. Yeah, seems we have everything. This is for debugging. Let me delete that comment. All right, we have everything ready. Then we can move to the next swap. To make things faster, I'm just going to define all the parameters I need, all the address of the routers I need for this constructor. So for Uniswap V3 is there, Pancakeswap V3 is there, Aerodrome, we need Aerodrome. We need the Aerodrome address for factory. We need alien base, and we need Sushiswap V3 router. Then we are going to come down here and just define the contracts. Wrap them around their interfaces, their respective interfaces. So we need to define all these contracts now. Then we'll come here and declare these contracts. All right, so now we are ready to call the remaining dexes: alien base, Sushiswap V3, and Aerodrome. All right, for Sushiswap, what do we need? Let's check what we need. We are calling these exact tokens for tokens. We need to specify path. We are not going to use get amount out because of this reserve in and reserve out. It's difficult to get the two of them. So again, we are still going to use calculate minimum amount to calculate our slippage. So here is the function to swap on Uniswap V3.